Now that we've talked about what maximum and minimum are in response to local and global, and we've talked about Fermat's theorem and how this occurs at critical points, we're now going to look at our first and second derivative tests, which can help us find these even more. So we'll start with the first derivative test. In our first derivative test, we're going to start by assuming that f of x0 is a critical point of our function. So it either exists at that point or it's either 0 or it doesn't exist. So now what does the first derivative test tell us? The first part tells us that if the first derivative is positive when x is less than our critical point and negative when x is bigger than our critical point, then we have a maximum value. Similarly, if our first derivative is negative when x is less than x0 and positive when x is greater than x0, we have a minimum. So this can seem really complicated and difficult to remember, but it's actually not too bad. And let's do a couple of examples to demonstrate how to set up this problem and then how to remember whether it's a maximum or a minimum. Here's my first example. F of x is x cubed plus 9x squared plus 24x minus 8. If I take my first derivative, I get 3x squared plus 18x plus 24. I want to set this equal to 0. I'm going to go ahead and factor out a 3 on the right-hand side. X squared plus 9x minus 8. Sorry, plus 6x minus 8. So now, dividing by 3 and factoring, I have plus 8. X plus 4 and x plus 2. So negative 4 and negative 2 are my critical points. Now let's consider whether our first derivative is positive or negative. To the right of this is a number like 0, and f prime of 0 is going to be positive 24, so that's positive. To the left is negative 5, and it might be easier to think of our derivative now in terms of our factored form. Negative 5 minus 4 is negative, and negative 5 minus 2 is negative, and negative times negative is positive. A number in the middle, like negative 3. Negative 3 plus 4 is positive, and negative 3 plus 2 is negative, so we have negative. So now, which one of these is a maximum and which one of these is a minimum? Well, remember, positive means our function's increasing, negative means it's going to switch to decreasing, and then positive means it starts increasing again. So we have a maximum at negative 4 and a minimum at negative 2. Let's look at another one. F of x equal to 1/5 x to the 5th, 1/4 x to the 4th, 1/3 x cubed, and 1/2 x squared. When we take our derivative, we end up with x to the 4th plus x cubed plus x squared plus x. We can factor out an x. That gives us x cubed plus x squared plus x plus 1. We then need to factor by grouping. We can pull out an x squared. That leaves us with x plus 1. And then pull out a 1. That leaves us with x plus 1. So I have x plus 1, x squared plus 1. So this works as 0 and negative 1. You'll notice this last term does not have real solutions, so it doesn't give us any new critical points. Let's start considering numbers. For f of 1, or f prime of 1, once again, the factored form makes this a lot easier. I have a positive number times a positive number times a positive number. That will be positive. For a number like negative 2, I would have negative 2, negative 2 plus 1, and then negative 2 squared is positive times 1, which will be plus. For a number like negative 1/2 in the middle, I would have a negative times a positive, which will be negative. So I'm increasing, decreasing, and increasing. So -1 is my max and 0 is my min.